All right, section 3.4 is about functions and their inverses. And I'm just going to do a couple of problems out of this section. I'm going to first do problem number 17, where they ask you to graph the function and its inverse. So the function they give us is f of x equals x to the third power minus 2. So the first thing I want to do is make a graph of the original function. So I'm going to plug in some numbers for x. I'm going to plug in -2, -1, 0, 1, and 2. And I'm just plugging them in for x and doing the arithmetic that goes with that. So -2 to the third power is -8. -8 minus 2 gives me -10. Then plug in -1. -1 to the third is -1. -1 minus 2 is -3. Plug in 0. 0 to the third is 0. Minus 2 is -2. Plug in 1. 1 to the third is 1. 1 minus 2 is -1. And finally plug in 2. 2 to the third is 8. 8 minus 2 is 6. So I can plot these points on my graph over here to get an idea of what the shape of this graph will look like. So I've got -2, -10, -1, -3, 0, -2, 1, -1, and 2, 6. So my graph is going to kind of have this sort of snaky looking shape to it. Now, that's the graph of the original function. An inverse function is always a mirror image of your original function if you put your mirror on this diagonal where y is equal to x. Well, it can be kind of complicated to do that graphically and try and flip this around that axis. So here's a trick that I like to use. If you have this list of points and you want to figure out the equivalent points on your inverse function, all you have to do is flip-flop the x and y coordinates. So for example, this point that was -2, -10 on the inverse will be represented by -10, -2. So I'm just going to go down this entire chart and just reverse every single one of these ordered pairs. Alright, now I'm going to plot each of these points and then draw a line, or in this case a curve, that goes through those points, and that will be representative of my inverse function. So -10, -2 is over here. -3, -1 is here. -2, 0. -1, 1. And 6, 2. So then I end up with a graph that looks something like this. And if you look at it carefully, you can see how the red graph is a mirror image, if you flip it across that dotted line, of the original graph.